Welcome to day 2 of EIGRP series. Guys, in day 1 we had discussed how EIGRP router will calculate metric, and today in this video we are going to discuss what are the types of messages in EIGRP, right? There are 5 types of messages, so we are going to cover 5 types of messages in this video. We will also discuss what is active state, what is passive state, what do you mean by stuck in active state, right? Each and everything. After that, I will show you practical as well, right? But first of all, let me talk what are the 5 types of messages in EIGRP, okay? So let's begin. So types of messages in EIGRP, right? First type of message is hello message. Second type of message is update message. Third type of message is query message. Fourth type of message is reply message, and last one, fifth type of message is acknowledgement message. Guys, first of all, let me know you these 3 messages, right? Reply message, query message, and update message are the reliable message, right? But if you might have thinking that EIGRP is a layer 3 protocol and TCP is responsible for reliability, right? So EIGRP is not using TCP. So how these 3 messages are reliable message in EIGRP? So guys, here is one protocol, that is RTP. RTP protocol is responsible to make these 3 messages reliable message, okay? RTP stands for Reliable Transport Protocol. Which EIGRP use this protocol to make these 3 messages as reliable message, okay? Now let me discuss every types of message one by one. So first of all, we are going to discuss hello message. So what is the use of hello message? Hello message is used to discover neighbor. Hello message is used to discover neighbor, and there is 2 use of hello message. First one is discovering neighbor, right? Hello message is used to form neighborship between 2 routers, and second use of hello message is keep alive, right? Let me erase this. Right? So first use of hello message is form neighborship between 2 routers, right? Suppose we have 2 routers, this is my R1 and this is my R2, right? Suppose IP address of this interface is 2L.1.1.1 and IP address of this interface is 2L.1.1.2. When I will configure EIGRP over here, how I will configure EIGRP, right? Router EIGRP and AS number, suppose 100. After that, network command. So we have to actually, when we run this command on this router, actually EIGRP process will enable on this router, but this router will not send hello message from this interface, right? Because we have to advertise this interface in EIGRP. Am I right? We have to advertise this interface in EIGRP. For that, you have to run network command. With the help of network command, we advertise prefixes in EIGRP, right? Or any other routing protocol. So network command is used to advertise prefixes or network in routing protocol. So network, after that, which network? 2L.1.1.0 and subnet mask 255. So you can put subnet mask as well as wildcard mask, right? Actually EIGRP works on wildcard mask, so when you will put subnet mask, EIGRP will automatically calculate wildcard mask. So wildcard mask will be 0.0.0.255, right? And enter. After that, this this interface will join the multicast group, right? That is 224.0.0.10, and now this router will start sending hello from here, right? Hello. But when this router will receive this hello message on this interface, right, on fast Ethernet, suppose this is fast Ethernet 0/0, this is fast Ethernet 0/0. So when this router will receive this hello message on this interface, it will check destination IP. So in hello message, right, at layer 3, EIGRP will generate hello message, right? After that, at layer 3, it will hand over to IP protocol, and IP protocol will add IP header with the actual data, right? In IP header, there will be information of source IP 12.1, destination IP. What will be the destination IP? Multicast address 224.0.0.10, right? 224.0.0.10, and after that, protocol field. In protocol field, value will be 88. That means, and the actual data which is encapsulated with IP header is EIGRP. Am I right? Now, when this router will receive this information at this interface, right, it will check, R2 will check destination IP. So destination IP is 224.0.0.10. Okay, so am I member of this multicast group? No. So this router will drop this traffic. This router will drop this hello message. So we have to configure EIGRP on R2 as well. So see what happens when I will configure EIGRP on R2. EIGRP, right? When I will advertise this network, right, this interface will also join the multicast group 224.0.0.10. Am I right? Now when this router will receive hello on this interface, it will check destination IP. Destination IP is 224.0.0.10, and I am member of that multicast group, so I will check further information. Then this router will check protocol field. In protocol field, value will be 88. Then this router will hand over to EIGRP at layer 3, right? This router will hand over hello message to EIGRP, and I advertise this prefix in EIGRP, so this router will also send hello, right? This router will also send hello, right? In hello message, there will be some information, right? There will be some information. If that information will match, these two router will become neighbor. What are that parameter which must be matched, right? That parameter is AS number, autonomous system number. So I am running EIGRP 100 over here, so we have to configure 100 over here as well, right? If I am configuring AS 200 over here, then R2 is sending hello. In that hello message, AS number is 200. R1 is sending hello. In that hello message, AS number is 100. AS number is mismatched. Now R1 and R2 is not going to become neighbor, right? So to become neighbor, AS number must be matched. So you have to configure 100 over here as, right? Now AS number must match, AS number match. After that, router will check K values. So whatever K values I am using to calculate metric, the same K value R2 is using or not, right? Actually, when this message will send hello, it will send K value, that which K value I am using to calculate metric. So by default, this router is using K1 plus K3, right? Yesterday we had discussed, and this router is also using K1 plus K3 to calculate metric. So this parameter is matched. Now they will become neighbor, and after becoming neighbor, after every 5 seconds, these two router will send hello to their neighbor. R1 is sending hello to R2 after every 5 seconds, right? And R2 is sending hello to R1 after every 5 seconds, right? So why this after 5 seconds these routers are sending hello again and again, right? Because hello message is unreliable message, right? So when any message which is sending periodically, that means that message is unreliable. R1 will never get acknowledgement of this hello message, right? R2 will never get acknowledgement of this hello message, right? So that's the reason Why hello message is sending periodically, right? Because it is a unreliable message. And after every 5 seconds, this sorter is telling to R2, yes, I am alive. I am alive, right? So there is two use of hello message. Number one, for neighborship. Number two, keep alive, right? So always keep in mind the use of hello message, right? That's it. Hello message is used to discover neighbor and keep alive. Use of keep alive. To tell, R1 is telling to R2 after every 5 seconds that I am alive. And R2 is saying to R1 after every 5 seconds that I am alive. Fine. Next type of message is update message. Let me discuss about update message. What will be the content in hello message? In hello message, there will be information of autonomous system, K value, right? Many more. We will discuss it at the time of practical. Don't worry. Next type of message is update message. Update message. What is the use of update message? Update message is used. It is used to share network information with neighbor, right? Update message is used to share network information, right? What do you mean by network information? Let me show you with diagram, right? Suppose we have two router R1 and R2. These two are connected to each other. Suppose I am configuring EIGRP over here, EIGRP 100, EIGRP 100, right? After that I will advertise this prefix in EIGRP, then this router will send hello, this router will send hello, right? If parameter will change match, then these two router will become neighbor, right? And suppose we have one LAN over here, right? And the IP address of LAN is 10.1.1.0/24. So when I will advertise this prefix in EIGRP, this router will send update, right? This router will send one update. Why update? To share the network information to neighbor. So what is the use of update message? Sharing network information with neighbor, right? So with the help of update message, R1 will send this prefix information to R2, right? In this update message, there will be this network 10.1.1.0. After that, network length 24. After that, bandwidth of receiving interface, delay, MTU, reliability, and many more information will be there in update message, right? But this router will send one null update first, right? Which update? Null update. There are two types of update, right? First one is null update and second one is main update, right? Main update. So in null update, there will be no information of any network, right? Actually, what is the use of null update? Null update is used to check bidirectional connectivity. Actually, why we build TCP connection, right, at layer 4? To check bidirectional connectivity, but EIGRP is a layer 3 protocol, right? EIGRP is a layer 3 protocol. So null update is used to check bidirectional connectivity because there is no any TCP connection. Fine. So after that, after null update, it will send main update, right? This router will send main update. And this router will also send one null update, right? Null update. And update messages are reliable. So suppose this null update is sending with sequence number 1, right? So this router will send acknowledgement of this null update. So in null update, they will acknowledge as well, and sequence acknowledgement number will be 1. Then this router will came to know that yes, my first update which I send with sequence number 1 is received by R2, right? That's why it's acknowledging at acknowledgement number 1, right? And it will put their sequence number as well. So sequence number, suppose 2, R1 is sending 1, R2 is sending one null update to R1, right? And using sequence number 2, and then this router will acknowledge at acknowledgement number 2, right? Now when this router will receive acknowledgement, this router will came to know that yes, this router R1, my neighbor router, received my null update, right? Now bidirectional connectivity is done. After that, R1 will send actual update, right? In that update there will be information of this network, right? So what is the use of update message? Update message is used to share network information with neighbor. Let me discuss third type of message, that is query message. And there is two use of query message as well. There is two use of query message. Third message is query message. Just suppose the same scenario, suppose we have R1 and R2, two router, right? Guys, actually now I am making you clear each and everything. That's why I am drawing a small topology, right? We will practical in large topology as well. Don't worry, you will learn each and everything about EIGRP in this series, okay? So suppose we have one network 10.1.1.0/24, right? So this router will share this network, this prefix with R2 via update message. And suppose after some time this network will goes down. If this network will goes down, then R1 will share one query message. Which message? Query message to R2, telling that if you have a prefix, if you have information of this prefix 10.1.1.0 via me, then remove that prefix from your routing table because this network is down. So first use of query message is to inform neighbor if network will goes down. If network will goes down, router will send a query message to their neighbor to let them know that network goes down. If you have prefix via me, please remove this prefix from your routing table. First use of query message. And second use of query message is, just suppose we have topology like this. Okay, let me draw one R1, R2, R3, R4, and here is one switch. Okay, suppose this is my topology. This is my topology. I am using EIGRP over here, right? And here is one prefix. Prefix is 10.0.0.0/8, right? Now suppose I am using serial link over here. Which link? Serial link. Serial link. Fine. Now R1 will calculate FD for this network, right? Yesterday we had discussed. R4 will also calculate FD for this network. After that, this router will share one update. In that update, there will be information of this network with metric and delay. In the same way, R4 will also send. Actually, this router will calculate FD and it will make entry in their topology table that there is one network 10.0.0.0/24, right? 4, and FD for that network is and this is my successor. This is my successor. In the same way, this router will also install. But suppose this router will get list metric via R2 because I am using serial link over here. So for R2, this path will become successor, right? This path will become successor. And for R1, if suppose there is no successor for this network, there is no successor for this network. So this prefix is successor, right? So this router will install this prefix in their routing table as well. 0.0.0/24 connected to my fast Ethernet 0/0. Suppose this is fast Ethernet 0/0, right? Let me talk about R1. right? Let me talk about R1. So R1 will also receive this prefix from two sides, from here and from here, right? But R1 will receive via R3 because I am using serial link over here. So this router will get list matrix from this side. So this router will install this prefix in their routing table via R3. Fine. Suppose after some time this link will goes down. If this link will goes down, then this router will generate one query message to let know to R1 that this prefix goes down. If you have a route via me, then please remove that route, right? Because I am not reachable. So actually this router will put delay as infinity, right? That means delay is infinity for this network. Then this router will come to know that yes, I have to remove this route from routing table via R3. First use of query message, and second use of query message is query message. R3 is asking to R1 that do you have alternate path? If there is no feasible successor, right? If there is no feasible successor in topology table, then only this query message will generate to ask do you have alternate path. So if a router have a feasible successor in their topology table, they don't ask they don't ask to neighbor do you have path or not, right? But if router don't have feasible successor in their topology table, then router will ask to their neighbor router, hey, do you have path to reach in this network? Then this router will ask to their neighbor, right? This router will ask to their neighbor, do you have path for this network? This router will ask to R4, and these routers are telling remove 10.0.0.0 network via me as well, right? With the help of query message, and asking do you have alternate path? Do you have alternate path? Do you have alternate path? Now this router have alternate path, right? So this router will generate reply. Then this router will also generate reply to R1. Then R1 will reply to R3. Then R3 will install this prefix via R1. So there is two use of query message. Number one, to let know to neighbor that my network goes down. If you have path via me, please remove that path from routing table. First use. Second use, to ask to the neighbor, right? Do you have path to reach in this network, to destination network, to remote network? Do you have path? And then router will reply. So if this router is sending a query, right, this router will wait for 180 seconds. This router will wait for 180 seconds for the reply. If within 180 seconds this router will not reply, because this router is also asking for neighbor, right, from neighbor. So if this router will not get reply within 180 seconds, this prefix will goes in active state. Actually when this prefix will goes down, this prefix will goes in active state, from passive to active, right? Passive to active. Now this prefix is in active state because this router is asking to R1, do you have alternate path, right? So now this prefix is in active state, and if this router will not get reply within 180 seconds, this prefix will stuck in active state. This router will stuck in active state. Let me make you more clear with one more diagram. Okay, suppose we have topology like this. This is my R1. No, let me change the color of paint. Suppose we have one router R1, and this R1 is connected to R2 and R3. R3 is connected to R4 and R5, and R3 is also connected to R6 and R7. This router is also connected to R8 and R9. This router is connected to R10, R11, R12, R13, right? Like this. This is my topology, and suppose here is one prefix 10.0.0.0/8. Fine. So definitely this router will advertise this prefix with R2 and R3 via update. After that, R2 will send to R4, R5, right? Like this, right? So every router will get to know that there is one prefix 10.0.0.0. This router will install via R4, R4 will install via R2, R2 will install via R1, right? But suppose after some time this link will goes down. If this network will down, then R1 will generate one query message to let know to their neighbor that if you have a prefix 10.0.0.0/8 via me, please remove that prefix from your routing table, right? Because I don't have reachability. Now delay is infinity for this network, right? Delay is infinity for this network. And this router will ask to their neighbor that in query message, this router will ask to their neighbor that do you have alternate path for this network? Do you have? If there will be no successor in their topology table, but if there will be one feasible successor in their topology table, then this router will never generate query. This router will make successor to feasible successor, right? But now there is no feasible successor, so this router is asking to their neighbor R2 and R3. Now R2 will not reply, right? R2 will ask to their neighbor, right? R4 will not reply. R4 will ask to their neighbor. These routers are waiting for reply. If this router will not get reply within 180 seconds, this network will stuck in active state, right? And if a router will stuck in active state, that means router will break neighborship and they will form neighborship again. Fine. So topology in this topology, complete router, all router will form neighborship again, right? Because these routers are stuck in active state, right? So guys, this is query message and reply message. What is the use of reply message? If this router have alternate path, then this router will let to know to R1 via reply message. If this router don't have alternate path, then this router will let to know to R1 via reply message. So there are two types of reply message. First one is positive reply and second one is negative reply. If this router have path, then it will send positive reply, right? This router will send alternate path to R1. If this router don't have alternate path, so this router will give one negative reply to R1, right? So if negative reply are there, no problem at all, there is no alternate path. But if this router will not reply within 180 seconds, then this router will stuck in active state, right? In active state. And when this prefix will goes in active state, when this prefix will goes down and this router in active state, means that this router is asking to their neighbor that do you have path, right? Do you have path, and waiting for reply. If this router will not get reply within 180 seconds, this router will stuck in active state. That's all for today, right? And acknowledgement message is used to acknowledge, right? Acknowledge, just like update message is reliable message. So after sending update message, R1 will wait for acknowledgement, right? Every router will wait for acknowledgement, right? And guys, there is one more thing. If you run show IP EIGRP neighbor, then you will see there is one SRTT time, you will see one RTO time, you will see Q count, right? Q count, and you will see sequence number. So we will discuss these terms in practical at the time of practical. So in next video I will show you how to configure this thing. I will show you how router can stuck in active state, right? How router generate query, how router will reply, each and everything we will discuss in practical. So this is day 2, and in day 3 we will discuss practical. Okay guys, that's all for today. Bye bye. Thanks for watching. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel. Bye bye. That's all for today.